Alright everybody, so this one might be one of those videos where you have to rewatch some of it. It's a little bit difficult to get the idea from the notes, but bottom line is this time you're going to be looking at equations where it's an exponential equals an exponential. And the goal here is we're going to make the bases of each side be the same thing. And so whenever the bases are the same, then you just set the exponents equal to each other. This is really hard to understand from just from descriptions and verbal descriptions, so it really helps to look at something like this down here. So here I'm looking at an exponential equal to an exponential, and the base here is 2, the base here is 8. Now those bases are not the same. If I can find a way to make them the same, then I can just set the exponents equal to each other. So what you do is, since 8 is a power of 2, which is to say that 2 can be raised to some power to get 8, then we're going to rewrite the 8. We're going to change it to match the same base as the 2. Okay? And specifically, 2 to the third power would give us 8. So that's why this, I mean, again, it's a 2 right here because it has to match that 2 right here. And then this little 3 right here, we're creating it and putting it in there, multiplying, key thing there, multiplying this top original exponent because 2 cubed is 8, that's where the 3 is coming from. Okay? Again, you looking at the notes, it says, to what power can the smaller base be raised to equal the larger base? Well, here, 2 can be raised to the third power to make it 8. So I need that 3 to multiply the exponent up here, and by doing that, that allows me to change that base. Okay, complicated as that is to see in notes here, the main thing is once you accept that and you've done that, then you just set the exponents equal to each other. So x minus 2 equals 3 times x plus 2, and you just solve it like normal. The best thing we can do here is just to see an example. And here, this is a great way to start because it's just the bases already equal each other. So I don't have to do the complicated part. I just get to see the immediate, like, how do I solve this part? If the exponents already equal each other, then just, if the bases already equal each other, then just set the exponents equal to each other and solve it. So 3x plus 16 is equal to 2x minus 1. Subtract the 2x, subtract the 16. Okay, so 3x minus 2x is just x, and negative 1 minus 16 is negative 17, and well, then that's the answer. So like I said, in a simple case when the base already matches, then just set the exponents equal to each other and solve that like normal. It's kind of like when you have log equals log and you cancel the logs. It's basically the exact same concept. Okay? But when you don't have bases that are exactly the same, then we have to change that base to make it match. So here's the thing. 4 is a power of 2. Specifically, 2 to the second power would give me 4. Okay? And so here I'm making the larger base, I'm changing it to match the smaller base because it's becoming the 2 that's matching the smaller base right there. But then it's squared because 2 squared is 4. So then now what I do is I multiply this exponent up here times the original 5x minus 1 right here. And so now I've changed the base to make it match. Now all I have to do is set the tops equal to each other and solve it. So now I have x plus 16 is equal to 2 times 5x minus 1, and distribute the 2, and I get 10x minus 2 equals x plus 16 minus x, add 2, what is that? Let's see, that's 18 equals 9x, so then x equals 2, because you just divide both sides by 9. Alright, and then here, oh my gosh, it's a fraction, but we can handle this. I'm looking at the smaller base, and when I say smaller, I'm comparing the 3 to the 27. Remember, when you have a fraction, you just look at, okay, 3 to what power gets me to 27? 3 to the third power gets me 27, but because this is a fraction, it's going to be the negative third power. So again, I'm going to change this 27 is going to become a 3. The 1 over 27, I'm going to make that base 3, and then the correct exponent that makes it match that number is negative 3. Okay, that's what this is all about, is finding the exponent that it takes to match, to make this equal that 1 over 27. So now I'm just going to multiply that negative 3 here times the original exponent there. Now the bases match, so I set them equal to each other on the exponents. X minus 2 will equal negative 3x, and then just solve it. So subtract x on both sides. Negative 2 equals negative 4x. Divide both sides by negative 4, and I get a half. Positive a half, because both of those are negative, so x would just equal a positive half. Okay. So again, the main idea is to get you have two bases that are not the same. I need to make the bases the same. So what I'm going to look at to see is what power can I raise, in this case 3, to make it 1 over 27. Well, that was my negative 3 here. So by changing this 1 over 27 to a 3 and giving it this exponent, it's still 1 over 27, but now it matches this base. Okay, and what I did is I multiplied this exponent times my other one here, my new one, the negative 3, and at that point, once bases match, you set exponents equal to each other, you solve. That's the main idea right there. Alright, you might need to rewatch it. If you do, please take all your time on it so we can be successful on this for tomorrow. See ya.